Thanks to God for the opportunity to share this lesson learned about pipeline corrosion behavior and performance. In this particular session, I'd like to focus on machine learning on the engineering management aspect. We will take 20 minutes with a 5 to 10 minutes for questions and answers. And I'd like to indicate one disclaimer, which is that the views, judgments, opinions, and recommendations expressed in this seminar or this webinar do not necessarily reflect those of Saudi Aramco, nor is obligated to adopt them. Without further ado, let me I'd like to start talking about our...
Rafi, sorry to interrupt. Is it possible to increase the size of the presentation or click present? Now we can see the overview of the PowerPoint.
The overview of PowerPoint. So let me just increase it. So let me know if you can see it. Okay, let me just do that. Oh yeah, perfect. Let me just do that. So I'm gonna do slideshow. Let me know that. How about now?
Now it's perfect. You can go ahead.
Oh, fantastic. Perfect. So when it comes to business needs and opportunities, you will notice that in the pipeline business around the planet, whether it's North America, South America, Europe, Asia, and Middle East, our pipelines are either from the 40s, 50s, 60s, and 70s. So the aging process is kicking in many of those older pipelines, becoming a challenge that tied up with the current oil and gas variability in the market, becomes a challenge for corrosion when it comes to mitigation, assessment, monitoring, and prevention. However, we got opportunities out there. So we, as many companies, we have collected large data sets. And those data sets, as Maya mentioned, they come with variables, with features that even though that they change over time, we can start selecting those ones to understand the corrosion behavior. What we do know now is that the corrosion behavior is dynamic. I understand that we do 2, 3, 5-year inspection intervals in some of the pipelines, but we know that corrosion is changing because it's like, I mean, you go to the doctor every year for your annual check or annual checkup, but also you need to check daily or weekly how your temperature is or how your blood pressure is, depending on the case. So because the nature is changing, so there is a behavior associated with it. That leads me to basically get into the explaining why the traditional software and the machine learning, as Maya explained, can become an opportunity if we know how to play with both, how to interact with both. We will describe the big picture of the corrosion machine learning model, and then we will discuss this engineering approach where we combine the CRISP VM methodology, which is a machine learning standard process, with the corrosion management process, and how we basically harmonize these two into one. And that will lead us to basically share some of those lessons learned that we have seen by developing these machine learnings. So as Maya mentioned, in the traditional software, we have a fixed formulation, right? And that fixed formulation gives us results that we apply as part of the regular planning in corrosion, whether it is in land inspection or the regular decks that we need to do, or whether it's the inhibition that needs to be applied and so forth. So, and then we cycle it. But what if we had this dynamic model that would, as a machine learning model, that would also take that input data simultaneously, and by the combination of these either neural networks or supervised and unsupervised or time series modeling with the human contribution, with the SME contribution, we empower our process to basically figure out that dynamic behavior that would help us to learn whenever something changes, how that change will affect. It's like when you go out for a walk. So your blood pressure will increase. If you go into running, it will be even faster. You just need to know what the ranges are and what is expected to happen. So you do some prediction. So how these two, fixed formulation and machine learning, work together? So we learned that by taking the results from different traditional softwares into the machine learning models, it could help us to start fine-tuning some of the behavior, understanding that there is a time-related stamp or time context that needs to be factored in. But those coming in combination with the individual data, it will help us to define better behavior. And that behavior, like the coefficients or the weights that we are developing, or maybe the introducing the causality, which what I mean is, what are the true causes of corrosion? Remember that corrosion in a given pipeline may not be caused by the same thing as another pipeline, because there are different conditions, temperature, flows, soils, and so forth. So the rules change. So we will be now talking about, in addition to this regular planning, we will talk about an evergreen planning. So there will be dynamic answers that would allow us to do better planning. So if you plan to do 20 decks in 5 years, maybe during the first year, you may change that number depending on what you are learning and depending how the new demands in the market are, how the weather is basically affecting the soil, how the corrosivity of the flow is changing, and so forth. Because that variability in the reality is now into the system, and that will go back into the brain with the human contribution to actually be part of the team. So that means that we could build a big picture where we are no longer talking about answers. We are talking about behavior. So we are talking about no longer about the static, yes, no, 10 or 20. We are talking about the behavior, the dynamics of how things change. And if we know the behavior, whatever we do, if we change the inhibition and maybe it rains and we get a salty soil, more salty, we can actually start paying attention to the performance. And that performance would allow us to do better predictions to interact back and forth into what the softwares need to do, or the actions need to be taken, whether it is on cycle basis or on demand basis. So let me talk about a little bit of the process. Maya mentioned that we needed a process, and that process has been already outlined out there. It's called CRISP. And this is, CRISP stands for Cross Industry Standard Procedure for Data Mining. And this process has been really helpful over the years to basically understand how to play with the data, how to understand it, prepare it, model it, evaluate it, and deploy it. But when you have phenomena such as corrosion, additional factors need to be played in. And we will look into that in a minute. That phenomena, well understood, will lead us to seek for knowledge, which is what we all are doing in this seminar, looking for knowledge that will make changes in what we will do with that knowledge, and maybe making some synergy with others, as we are doing in this seminar, connecting with others, and see how can we progress all together. Because sooner or later, the end result will be that we all grow as individuals, as families, as society, as a planet. So there will be a talent growth associated with that combination of sciences and skills. And as we develop these new processes, some criteria will be required to sustain that new process. So business sustainability, we will talk about that. And once we have the first pilots running out, there will be an opportunity for us to say, we need now to adapt that to this new condition and scale now that we have managed the behavior. So it will be a continuous learning that we wouldn't stop. Machine learning is the great opportunity for imperfection, because we will be working towards to perfection. We will work into, and it will be an ending, a continuous improvement process. So let's talk about corrosion dynamics. In our particular case, we are talking about transmission pipelines that by essence, they have some characteristics as far as the flow qualities, but at the same time, they continue being corrosion. So they continue having a dynamic behavior, so it changes over time. And we know that the hydrocarbon quality that changes as well, because the wells, there are new wells, there are old wells, there are wells in the middle, there will be a change in the corrosivity. What we do now is that whatever is happening for that particular flow, there will be causal factors. Causal factors meaning some of the threats that we call in this case corrosion will be triggered by hazards. So we start understanding the hazards. In this case, I mean hazard, whether the velocity, or we are talking about the age, or we are talking about the chemistry, or we are talking about the inhibition treatment. So we will start understanding where is this all phenomena coming from. And we will know that the phenomena will have two main things. There will be new anomalies, and there will be anomalies that are continuously growing. And also there will be one more factor, time. So everything will be called, it will be framed with time. That's when we talk about corrosion states. So there will be a corrosion state, maybe just initial, or maybe have a corrosion state where we have an active corrosion state, or maybe we have a passive corrosion state, and maybe the cycle is all over again for change A or change B. As well as we are going to have a location dependent, because we have an asset that is linear, is continuous. So now that we have a better understanding of what the phenomena is, now we need to know that that knowledge will be segregated. So there will be, corrosion caused by bacteria is not the same as corrosion caused by for the atmospheric conditions. It's not, if we will know that the operation changes, whether increase the flow, decrease the flow, or whether we apply more inhibition or less inhibition, will lead to changes. So changes with or better understanding from the research and development as far as the behavior goes for those type of corrosion will need to be merged and will be captured within the machine learning modeling. I'll give you an example. We have learned that machine learning models are plural when it comes to one solution. What I mean by that is, if you want to resolve or you want to focus on one solution, you are going to need to look into multiple machine learning types. I'll give you some of those cases. When you are looking at causal factors, you are going to need to look into the unsupervised. Like Maya mentioned, you're going to need to be doing some clustering. But at the same time, machine learning models go by correlations. They don't go by causation. So you are going to need to complement those unsupervised models with some specific structural causal modeling that will help to contribute with the unsupervised one. But once you do that, then you're going to need to get into the supervised modeling to do more of the work associated with corrosion degradation. And moreover, you may need to go into time series, and they start developing some of the specialized machine learning model that will allow to establish the corrosion states over time. And that needs to be reflected on some sort of a platform, and that's where the digital twins come in. Digital twins have been enable us to take machine learning information and put it into a kind of a color-coded graphics where we see how it changes, like at your veins or your arteries. So you see how the flow runs and how your artery may be in one area more affected than in other, and then the colors will change. In summary, we are going to need to do a synergy, not just the knowledge, also the disciplines of the people that work with us. That's why the talent growth becomes really important. So we learned from the very beginning that getting engaged with multiple areas, whether our research and development, whether it is the specialists from machine learning, whether it is the subject matter expert from corrosion, from operations, from maintenance, will make a difference. And getting them, even though that they don't have some of them, they don't have the obligation to do training, they would basically start learning about machine learning when it comes from corrosion. And the guys from machine learning will learn about corrosion. So there will be a complementary, so the language, as May said, will be linked. So training via workshops on the job, which means the acceleration on in-house growth becomes important. Whether you get the support from contractors or not, the in-house growth becomes the base to basically build the long-term model. And that leads me to the business sustainability. We call charters those documents that provide a well-defined governance, where it defines who does who in this process, who is responsible for doing those models, who is responsible for working with the programmers, who is responsible for reviewing, conducting oversight, who is responsible for making decisions. So that governance becomes important. Open source programming becomes the basis to do everything. We understand there are multiple softwares out there, and some of those softwares can be used for applications, but the open source is the way to continue growing and adjusting without too much customization of fixed software. However, at the more higher level, corporate level, it becomes very, very important, the need for developing digital roadmaps, where the corporation has a roadmap of machine learning that is connected with other roadmaps associated with whether it's UAVs or associated with Internet of Things, that they are connected, because at the end of the day, it's one business and it's one objective or one goal. What that means is changes will happen, and we expect to be part of that change, and we will have processes, or we will need to use the existing processes for managing the change. Once we have platforms in place, it's important to understand that nothing is perfect, made by humans. So pilots will be kind of at the leading edge to move things forward, that will be coming to production. But those platforms, they need to be ready for improvements and scaling to move it to the next level, whether it's other services, would allow us to start harvesting the results that we look for. So it is a continuous improvement. Like anything in human, we need to wake up every day, and at least for myself, I need to say to myself, Rafa, you gotta be better today, better than yesterday. You didn't have to be perfect, but you will do better today, and that's the commitment. So thank you.